Now that we've created a package in the previous video, let's write a Python publisher and subscriber node that makes the turtle in the turtle sim avoid the walls of the turtle simulator. It's good to have a prior knowledge or understanding of how your Rust program will work before starting to write code. One thing you want to establish first is what type of interface or communication is needed to run your code. In this case, we want to know when the turtle is close to the wall. Make it avoid the wall by turning, continue to move forward, repeat the cycle. This task can be broken down into two based on the kind of information we need from Rust. The first is make the turtle move forward and turn. Then the second, know when the turtle is close to the wall. These two tasks are handled by different topics and they use different data types for message communication. Your job is to first know which type of data they use for communication. Run the TurtleSim node to introspect. Use the Rust topic command to see the list of running nodes. The turtle uses the turtle1cmdevel topic to communicate information relating to speed, while the turtle1pose topic is used to communicate the position and orientation of the turtle. Now we know the type of topic to communicate to. Let's say the topic type associated with those topics. Turtle1cmdevel uses the geometry msgs/msg/twist topic type, and the turtle1pose topic uses the turtlesim/msg/pose topic type. It's great to see all these because we need them in our code. But one last thing, let's now see the data types used and not just the topic type. Use the Rust2 interface command to introspect on the type of data used by the topic types. So geometry messages message twist uses vector 3 linear and angular, while turtlesim message pose uses float 32x, y, theta, linear velocity, and angular velocity. On your terminal, go to the turtle control package and create a folder called scripts, which is where we will put our Python codes. Use the touch command to create a Python executable and call it avoidwall.py. Go back to the workspace and open VS Code or any convenient text editor from there. Our Rust code depends on some files which we will import before writing the main body of the code. The first import is the Python Rust client library. The second import allows us to use the node class in the Rust client library, while the last two are the message interface our code is going to depend on. We start by creating a class avoidWall with the node object. Declare two variables to store x and y position of the turtle. Initialize some attributes of the node. The first is the node name, which is called avoidWall. Create a publisher that publishes the speed of the turtle to command velocity. It takes three parameters: the message type, the topic to publish to, and a queue size of 10, which is the quality of service settings. Quality of service QoS is a policy that helps in handling communication between nodes and how traffic is prioritized. According to Rust, the default QoS settings for publishers and subscribers is 10. Create a timer that will run a callback every 50 milliseconds or 0.5 seconds. The create timer method takes two parameters: the time period in seconds and a callback function, which is the function you want to run for that time period. Lastly, in this function, we'll create a subscription to the pose of the turtle. The subscription takes four parameters: the message type of the topic to subscribe to, the topic to subscribe to, a callback function that executes whenever there's a subscription to that topic, and lastly, the QoS. To make the turtle avoid wall, we need to know where the turtle is. So we'll write a function called postCallback that takes two parameters, self and turtle pose. Remember the variables inside turtle same message pose. They are x, y, theta, linear velocity, and angular velocity. To get the position of the turtle, we only need x and y. Use the dot operator to access attributes of the pose message type. Access the x and y attributes and store the value in pose x and pose y respectively. Now let's write the callback function that uses information from the post callback to avoid the wall and publishes the velocity command to the turtle. Firstly, we get the pose x and pose y and store it in x and y respectively. Create an instance of twist and call the name speed. Use the dot operator on speed to access the attributes of twist, since speed is an instance of twist. Remember, twist contains linear and angular velocities. Use the dot operator to access the linear velocity in x-axis and assign it a value of 2.0. It means the turtle will always move in the forward direction at a speed of 2 meters per second. The turtle simulator environment is about 11 by 11 units dimension, and we want the turtle to turn when it approaches the extreme of the simulator, otherwise called wall. We will define a limit of 1 and 10. So let's set a condition for the robot or turtle to turn. If the pose in x direction or x-axis is less than or equal to 1 or greater than or equal to 10, or the pose in y direction is less than or equal to 1 or greater than or equal to 10, we want the angular speed of the robot about the x-axis to be set to pi value or 180 degrees. If that condition is false, the angular speed should be set to 0. Let's publish the speed to effect the changes in value. Nothing will move if we don't publish the speed. We will execute our program in the main function, initialize the node with init, create an object of the avoid wall class, use spin to process the object until the shutdown is called by a process like Ctrl+C on your keyboard. Finally, run the main function. We are done with the code. Let's set up the compilation structure for it to run. It's important to know the build type used to create the package because the compilation setup depends on the build type. We used Ament CMake as our build type, which requires us to set up some files and folders before we can run the code. Create a folder under the package directory. The name of this folder should be the same as the package name. Inside the new directory, we'll create two files, __init__.py, which will host any library or module we want to use. And the second file is module_2_import.py. Give permission to make the file executable using chmod. Now, let's make changes to the CMake list file. Find and load required dependencies for the node. A Rust program depends on Ament CMake Python, the Rust client library for Python, geometry messages, and TurtleSim. Install the Python modules under the package. Install the Python executables in the scripts directory. Let's go to a package.xml. This is where we define what our package depends on. A package depends on the ROS client library for Python, geometry messages, and TortoSim. Save your file, build your package again from the workspace directory, and remember to source your workspace overlay. Now you can run the code to see how great it is. Beautiful. The turtle moves forward and subscribes to the post topic every time. When the pose value shows the turtle is close to the wall, an angular speed is published which makes the turtle tense as it keeps moving forward. There are few improvements that can be made on this code. For instance, you will observe that the turtle only turns to the left even when it seems turning right is appropriate in some cases. You can use the introspection tools to understand your ROS program. You've learned the most important basic structure of writing a node, a publisher, and making subscriptions in Python. You've also seen how to set up code configuration files to make them run as they should. In the next lesson, you will learn how to develop the same thing in C++.